We're going to be looking at proportional reasoning, and the method we'll use to solve this is algebraic reasoning. Our overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to solve for the unknown value in a proportion using a variety of methods, like we said, algebraic reasoning. So let's look at our inquiry type question. We'll read through it once, and then we'll highlight important information the second time through. A standard punch requires 2 cans of orange juice and 1 bottle of ginger ale. When using 4 bottles of ginger ale, how many cans of orange juice are needed for the punch? So let's highlight important information. Standard punch requires 2 cans of ginger ale. 2 cans of orange juice. And I'll highlight different color the other types of bottles. 1 bottle of ginger ale to build. When using 4 bottles of ginger ale, how many cans of orange juice are needed? Okay, so almost everything here is pertinent information. Let's set up our categories. OJ cans. We know that if we need 2 OJ cans to build punch, we'll also need a bottle of ginger ale in that relationship. Since this is a direct variation type question, and I'm going to use algebra to solve it, we need to build an equation. Okay, and our equation is going to be built off of this. Y is equal to m times x. Okay, and it's really going to depend on what we call our y and which we call our x in this case. A lot of times we call the x the independent and the y the dependent, but because we're building punch here, it could be said that either are independent or dependent. We know it's direct because if I don't have any bottles of ginger ale and I only have a can of OJ, I don't have a punch, I have OJ. And vice versa. If I only have 1 bottle of ginger ale and no cans of OJ, well, I don't have a punch either. I have just ginger ale bottles. So in order to build a punch, I need some of both mixed together for it to be a punch. So we know this is a direct variation. If we have 0 of one, then there's 0 of the other. So for argument's sake, the first way we'll solve this, let's just say OJ is our x variable. I'm not sure why I paused there. And ginger ale will be our y variable. Okay, so for every can of OJ, we have to build a rate. Our m is our rate here. So our rate is going to be per OJ. So how many ginger ale bottles per OJ do we need? So that means per, as in the value of 1. We need to turn OJ into a value of 1. Okay. And I guess that's why I was pausing when I was thinking before. It probably would have been easier if we set this up the other way, but we can do both. So we'll do the hard way first, and then if you watch a little longer, the second way we do this will probably be a bit easier. Okay. So we need to convert OJ from 2 to the value of 1, which one way to do this is by dividing by 2. It's probably the simplest whole number way to do it. So because we divide that by 2, we'll also divide our bottles of ginger ale by 2. And that'll either give you the value of a half or 0.5, which you guys might be more inclined to use a decimal. Okay, this 0.5 is our rate because OJ is now set up as 1. So OJ value is 1, which means our ginger ale is 0.5. So 0.5 divided by 1 is 0.5. That's our rate. M is our rate. So our equation now reads y is equal to 0.5x. Okay. So since we know the question's asking us if our y value is 4, so if there are 4 bottles, we're going to replace our y with the number 4. So 4 bottles of ginger ale. How many, 0.5, cans of OJ we need? And x is our cans of OJ in this case. So we need to isolate for x, okay? So because there's 0.5 on this side, and because it's multiplied by x, we can divide both sides by 0.5. Commonly known as canceling out, but really what it's doing is changing this value. It's actually increasing it to 1. A lot of times they call it reducing, but this is increasing the x value to 1, okay? So x is now 1x, so there's 1 value of x. And 4 divided by 0.5, if you take out your calculator and check, is actually a value of 8. Okay, so for 4 ginger ale bottles, okay, we need 8 OJ cans. So remember I said there was probably an easier way to do this. Let's set that up again. I'm going to set it up a second time. So OJ cans, we needed 2, and ginger ale bottles, we needed 1. Okay, and we knew that it was a directly proportional relationship. Okay, so we're setting up a y equals m times x. Okay. This is direct variation. Okay, we need a rate. Well, if we actually do a different type of rate where we go OJ per ginger ale bottle, okay, and per meaning ginger ale needs to be reduced to 1, well, it already is 1. So our M value is whatever our cans of OJ are. So M is equal to 2, right? Because we have 2 divided by 1, that equals 2, which is our M value, like we said. And that should be done in purple, technically. Okay, so our equation is really easy to set up now. Y is equal to 2 times X. Okay, 2 times X. Now, with this being said, though, and I didn't define this at the beginning, if that's going to be our rate, okay, that means our ginger ale is actually our X variable, and our OJ is our Y, which is the opposite of what we had before. Remember, ginger ale was Y and OJ was X. In this one, because this is our ginger ale, our rate is in X. So ginger ale bottles is X. So it's a little different this time. Remember, we knew that we needed 4 ginger ale bottles. So we're going to replace X with the value of 4, which works out really nicely because there isn't really any moving left or right or balancing the equation. We have 2 times our value of 4. So how many cans of ginger ale do we need? Well, 2 times 4 is 8. The exact same thing we found before. We need, for 4 ginger ale bottles, we need 8 OJ cans. Okay, so we set this up 2 different ways and essentially solved it. If you'd like to see other ways to solve this question, check out our other playlists on proportional reasoning.